Hi, I'm Ichi, a PhD student from Aalto University. My topic is computational workflows for designing input devices. Designing an input device is challenging. The motivation of my thesis is searching for better design methods that offer higher efficiency and robustness. The traditional procedures of designing input devices are more or less following the user-centered design flow, which typically contains design, implement, and analyze stages. And a good design is improved throughout iterations of these steps. This user-centered design has some major issues. First, building a new input device for each iteration is costly. Second, the design and analyze stages are highly dependent on the designer's experience and expertise, so there is a good chance they are biased. My thesis is trying to offer alternative solutions. Recently, computational interaction has become an increasingly important trend in HCI that offers leveraging optimization and user models to derive optimal designs. Successful examples include better user models, using optimization for designing tasks, adaptive user interfaces, and AI-assisted tools. However, these methods and tools for GUI-based interaction are hard to be applied for designing input devices. Here is why. Designing input devices should consider models of complex and continuous motions, which are not introduced to HCI yet. Also, rendering arbitrary properties of physical input devices remain challenging. Lastly, the optimization method in HCI are mostly single objective, but a good design usually considers multiple objectives. Therefore, I propose computational input design workflows. The key components include multiple objective Bayesian optimization, which searches for the Pareto-optimal design instances, and physical simulators to render the design sample by the optimization. Lastly, a meta-reinforcement learning user model will adapt to a new design instance quickly and provide evaluation performances. So far, my research has covered the optimization and simulation parts. The first work of mine, published in CHI 2020, is about push-button simulation and design. I developed a novel model to describe the characteristics of buttons, and further implemented an end-to-end simulation pipeline that covers from capturing a button to rendering its haptic properties. 6 buttons are tested, and the user study shows our simulation outperform the previous works. The second paper is aiming at using multiple objective Bayesian optimization to improve the design of interaction techniques. Prior works in HCI use single objective optimization to assist interaction development, which forces the developer to merge several objective metrics into one, which is not ideal, especially not ideal for objectives that compete with each other. The major benefit of multiple objective optimization is that it results in a series of designs on the Pareto frontier. This gives higher flexibility to the designers. This work is currently under review of Tokai 2021. The project I'm working on right now is a meta-reinforcement learning-based agent. Ideally, it will be able to adapt to new design instances quickly by leveraging the previous learned experiences. That is going to be the last component of this CID framework, but there are many other interesting research questions ahead. For example, scene-to-real transfer algorithms and more efficient optimization methods. Also, advanced controlling methods for higher precision simulation, and building simulators beyond push buttons. These are all open and challenging research questions. To sum up, my thesis contributes the computational input design workflows, and I further identified and implemented 3 major components ranging from optimization, physical simulation, and meta-reinforcement learning. I hope this thesis can bring physical interaction a step toward computational-oriented design process. That's the end of my talk, and thank you for your attention.